Hello and welcome to another CPD Shorts from Complete Maths. And this time we're looking at listing factors of relatively large numbers. So you can see here we've got 120, it's got quite a few factor pairs. And it's really easy to miss a factor pair if you're not working systematically. So to ensure we get them all, we're going to be using prime factorisation. So we're going to break down 120 into its product of prime factors. So because it's a multiple of 10, I'd always suggest taking your factor of 10 out. So we can write it as 12 times 10. And then this next step, let's consider 12. Well, that's 3 times 4. And 4 is 2 times 2. So it's 2 times 2, which is 4, times by 3, which is 12. And then 10 is 2 times 5. Now all these are now prime numbers. So this is the prime factorisation of 120. Now at this stage, what I like to do with my students is cut these out onto little pieces of card, and if you want to, you can colour code them as well. So I've got my 3 2s here, 2, 2, 2, and I've got a 3 and a 5. And the ability to move these around the page now helps when we're listing all these factors. So let's start with 1 times 120. That's the obvious first one because every single number has a factor of 1. And then we go down this left-hand column and we increase this number and see if it's a factor of 120. So if I try the number 2, is 2 a factor of 120? And we look at the prime factorisation. And of course, 2 is a factor of 120. It's 2 multiplied by all this. What's left? Now always look for your 5 and your 2, which is your 10. So you've got 10 times 6, or 60. Let's go back to the prime factorisation. Can we find a factor of 3? Yes, we can. And it's 3 multiplied by whatever's left. And we've got 10 and we've got 4, so we've got 40. Go back to the prime factorisation. Right, can we take 4? And here's a key teaching point, because a lot of students now might say, no, I can't find 4, but remind them of the fact that we can make 4 by doing 2 times 2 here. So this is 4, and its factor pair is the remaining prime factors. So we've got 10 times 3, which is 30. So we've got 4 times 30 as another factor pair. Does 5 go into it? Yes, it does. We've got 5 multiplied by all this which is left, which is 2 times 2 times 2, 8 times 3, 24. We've got 24 times 5. Now that might be one of those which potentially you could miss, because that's one of the tricky ones, I'd say, of 120, one of the trickier factor pairs. Let's carry on then. Is 6 a factor? And hopefully by now your students have spotted how this is working. Yes, we've got 2 times 3 to make 6, and whatever is left is its factor pair. So we've got 10 times 2, which is 20. And then the first number which is not in there, which is the number 7. And it's kind of obvious why 7 is not a factor, because we don't have this prime factor of 7. So we can't make 7, but we can make 8, because we've got 2 times 2 times 2, which is 8. And what's its factor pair? Well, 3 times 5, 15. Can we make 9? Well, no, we can't. We'd need another 3. But we can make 10. It's 10 multiplied by this here, which is 12. We can't make 11 because we don't have a prime of 11 in there. And the next number would be 12 itself. Now notice we've already done 12, and it's 12 times 10, so we've reached that pivot point where we just start working back down this list. So this is every single factor pair of 120. Working systematically, and we can't miss any factor pairs if we're using this prime factorisation. So, as always, hope you enjoyed this, and post any comments you have in the thread below.